Let's talk about the Pythagorean theorem. The Pythagorean theorem is used for right triangles, and what it says is if you have a right triangle and C is the side opposite your right angle, which is your hypotenuse, and also C is the biggest side and will always be the biggest side, and A and B don't matter quite so much, but when you have a right triangle labeled in this way, the relationship between these sides is C squared equals A squared plus B squared. Okay? So make sure when you're doing this that you're dealing with a right triangle. We will use this when we get to Part B, Pre-Calculus B, and we start talking about trigonometry. So let's just do a couple problems with it right now to get us ready for that. Here's my first example. I want to find the length of the third side of a, ooh, wow, that's amazing, I didn't mean to do that. Find the length of the third side of a right triangle if the length of one side is, well, I guess I need to fill that in, if the length of one side is root 3, and the longest side has a length of 2. Now I have to tell you that the longest side is length 2, because if I don't tell you that 2 is the longest side, we don't know whether 2 should be C or whether the number I'm trying to find will be my C, and that'll make a difference in my final answer. But since 2 is the longest side, I put 2 in for C, so I get 2 squared equals, and then on the other side, let's just let A squared be the one we're looking for, and root 3 can be B squared. And again, that one doesn't matter quite so much. So I get 4 over here, 4 equals A squared plus square root of 3 squared is just 3, subtract 3, and then I get A squared equals 1, or A equals 1. And even though I square rooted A squared, I don't do plus or minus because we're talking about a real world situation, and you don't want the negative, you don't want to talk about triangles with negative sides because that would be kind of weird. So let's move this, well, let's move this out of the way a little bit. Okay, we'll get this over to the side here so everybody can see. And no, I didn't move it very far, but and then let's get this out of the way too, and we'll do one more problem. And here's the problem that I want to do. I want to know if the following sets of numbers form the sides of a right triangle. So here are the numbers that I'm going to deal with. I just changed color again. Okay, so the numbers I'm dealing with are, let's say, square root of 8 and 3 and 1. Square root of 8, by the way, there is another way to rewrite that we'll talk about later. To do this problem, though, I need to figure out which of these numbers is the largest number, and that will be my C squared, because if I don't put the biggest number in for C squared, I'm definitely not going to have a right triangle. And what I'm going to do is I'm going to decide which of these is C squared, and I'm going to take the other two and put them in for A and B and see if I get a true statement. So we'll plug in square root of 8 for one of these numbers, and these other two will go up here for the other two, and see if we get a true statement. So let's see. I think the largest number is going to be 3, because square root of 8 is actually between 2 and 3. So 3 should go by itself. That's your C. And I'll put a question mark because I don't know if this is a right triangle or not. And then square root of 8 squared. And then plus 1 squared. Well, I get 9 on the left and 9 on the right. That is a true statement. So your answer is yes, this is a right triangle. If you got a false statement, it would not be a right triangle. So that's Pythagorean theorem, and I hope you enjoy using it as much as I do.